Hello, chemistry students. Today we are going to be starting the qualitative analysis experiment. Qualitative analysis is used to analyze for specific metal ions in a solution. For today, we're going to be starting with group 1, or the chloride group. And the chloride ion in acidic condition is the precipitating reagent for this particular group. This group consists of silver, lead, and mercury. However, we will only be analyzing for silver and lead. So let's go ahead and get started. Okay, so to start the chloride group, we're going to go ahead and we're going to add 10 drops or a few drops of our silver nitrate. And we will add an equal amount of our lead nitrate to the same test tube. Okay. We're now going to bring up the volume in the test tube to 3 milliliters with deionized water. I'm going to give this a little mix. Okay, to our test tube with our lead and our silver, we are going to add 3 drops of 6 molar hydrochloric acid. We'll now mix this with a glass stir rod. As you can see, we're getting a precipitate. After mixing, we're going to centrifuge our test tube. Make sure you have a balance. And we will centrifuge the precipitate down. Okay, so our centrifuge is stopped. We're going to remove our test tube. You can see we centrifuged down our white precipitate. Now we're going to add 1 or 2 more drops of 6 molar hydrochloric acid to make sure that the precipitation is complete. As you can see, we're no longer getting any more precipitate. So the precipitation is indeed complete. Now we're going to decant the solution from this. This would be your S1 solution. We will transfer S1 solution into another test tube. Now for today, we are only analyzing group 1 or chloride group ions. So we do not need to save S1. However, if S1 or if this solution had other additional ions from groups 2 through 4, we would need to save this for further analysis. And this would be your S1 solution. For today, we're going to discard it. Okay, so we're left with our precipitate, which is residue 1, R1. We're going to use our wash bottle and wash our precipitate with 1 to 3 mils of water. We use a stir rod to mix. Make sure it's washed. Now, we're going to centrifuge our washed precipitate back down. Okay, so our centrifuge is stopped. We're going to remove our tube. You can see the precipitate has centrifuged down. We're going to discard the wash. After discarding the wash, our precipitate or residue 1, R1, is now ready for further analysis of the lead and silver ions. To R1, we're going to add 3 or 4 mils of deionized water. And then we're going to heat this to near boiling with constant stirring. So we will heat this till near boiling. So R1 is continuing to heat up, and we are stirring it. And we will continue heating. Okay, at this point, we have heated our R1 mixture to near boiling. So we're going to centrifuge this hot R1 mixture Okay, so our centrifuge is stopped. We're going to remove our R1 mixture. As you can see, the precipitate has been centrifuged down. We're now going to decant the solution into a new test tube. This solution is solution 2, or S2. We will save this for further analysis of the lead ion. The remaining residue is residue 2, or R2. We're going to wash R2 with several portions of boiling hot deionized water. I have a test tube right here that I've been boiling with deionized water in it. So we'll wash. And again, after washing, we'll centrifuge. Okay, our centrifuge is stopped. We've centrifuged our precipitate down again. Residue 2. We're going to discard the wash. And we're going to wash again with several additional milliliters of boiling hot deionized water. And after washing, we will centrifuge one more time. So our centrifuge is stopped again. We're again going to discard the wash. As you can see, we have our precipitate remaining, which is residue 2 or R2. At this point, we're going to set it aside and analyze later for silver ion. Okay, so we're going to go back to our solution 2 or S2, and we're going to analyze for lead ion. In order to do this, we're going to add several drops of 1 molar potassium chromate. So we'll add several drops of the potassium chromate to our solution 2 or S2. Now a yellow precipitate will confirm the presence of the lead ion. And as you can see, we have a nice yellow precipitate upon the addition of 1 molar potassium chromate. That precipitate is lead chromate. Now we're going to centrifuge this. Okay, so our centrifuge is stopped. And as you can see, with the addition of potassium chromate, you can see that we do have a significant amount of yellow precipitate, and that confirms the presence of lead. Okay, at this point, we're going to go back to our residue 2. And we're going to test for the silver ion. In order to do this, we're going to add 1 milliliter of 6 molar ammonia to residue 2. And we're going to add 2 milliliters of water to residue 2. And we will stir. Okay, upon mixing, we're going to centrifuge. Okay, so our centrifuge is stopped. We're going to remove our test tube. And we're going to decant the solution. This solution is our S3 solution. Now our S3 solution should be clear before we proceed. And as you can see, S3 is quite clear. So we're going to move forward. Okay, so now we're going to acidify our S3 solution by adding 6 molar nitric acid dropwise until acidic. And we'll check that with blue litmus paper. So we'll add our nitric acid dropwise. Not acidic quite yet. Okay, so we're continuing to add just a couple more drops of nitric acid until we get our solution to turn acidic. But as you can see, we're starting to get some white precipitate forming. Okay. So you can see we've acidified our solution, our S3 solution. Now we're going to centrifuge this. Okay, so at this point, our centrifuge is stopped again. We're going to remove our S3, our test tube containing the S3 solution that we had acidified with 6 molar nitric acid. As you can see, we now have precipitated. We have a nice white precipitate. That white precipitate is a confirmation of the silver ion. All right, at this point, that concludes the test for the group 1 chloride group ions. You'll now continue on to the group 2 ions.